Farms matter. They matter to our food systems. They matter to our economy. As I saw on a bumper sticker recently, no farms, no food. As we all know, farms need water, and in the case of cattle farms, that means a fair amount of liquid waste. As we'll hear from our guest today, a farm with 2,500 dairy cows can produce as much liquid waste as a small city of about 400,000 people. So if we triple that number, it might be fair to assume that roughly 7,500 dairy cows could produce as much liquid waste as the city of Edmonton, and maybe around 9,000 dairy cows for the city of Calgary. To match Alberta's current population of about 4.6 million people in terms of liquid waste production, according to some quick back-of-the-envelope math, you're looking at around 29,000 dairy cows, which sounds like a lot of cows, but across Alberta, we have 80,000 producing dairy cows and a total cattle population of around 5 million. Now, these are rough numbers and very clearly based on hand-waving math, but they illustrate a point that farms can produce a lot of waste, and finding ways to recycle and reuse that waste is extremely important because, like we said, farms matter. And making them as sustainable as possible, well, it matters too. That's where livestock water recycling comes in, with a technology that essentially puts a little water treatment plant right on the farm to turn that waste back into things the farm needs. So we sat down with their co-founder and CEO, Karen Schuett, to discuss a technology we can use to make our farms more sustainable by extracting micronutrients from the waste and creating clean water economically. Here on Carbon Copy.
My name is Karen Schuett, and I'm the co-founder and CEO of Livestock Water Recycling.
What is the organization Livestock Water Recycling? What is it that you do?
We have a technology that we've created to treat wastewater from agricultural sources. Now, when I'm describing that to people out of the industry or people who don't quite know much about wastewater, I say our technology is like a mini water treatment plant that has been designed for application on farms and in agricultural settings. So this means we work with agriculture waste. First and most often, that means manure waste. But we also work with various forms of food and food production wastewater.
So then, if you don't mind diving maybe a little bit deeper, let's talk about the technology. How would you explain the livestock water recycling technology and how exactly it works?
Yeah, so I'll start a little high level about that because people, don't maybe understand how much wastewater is produced out of livestock facilities or agricultural facilities. So when we talk about that from some frame of reference, we would say a farm with 2,500 dairy cows produces as much liquid waste as a city with 411,000 people. So in Alberta terms, that means a dairy farm with only 625 cows produces as much liquid waste as the city of Red Deer. In Alberta, we have almost 5 million cows, in fact, more cows than people overall. So it's a large amount of waste produced. Our system is put in place to take that waste and turn it into valuable products. Mostly, we've talked about turning that wastewater into clean water that we can use. It's potable water. We can use it for irrigation, flushing, washing, cow cooling, cow cleaning, and even some places drinking water. So that's exciting. But the products that we pull out of the manure and food waste are valuable in many different ways as fertilizer, as energy production. So we want to pull value out of wastewater to create something beneficial. The technology itself is a skid-mounted water treatment plant. It's miniaturized for use on a farm, and it's automated so that you don't need wastewater treatment operators to make it run like you would in a city. But operates just basically the same way. It's specifically designed for manure, but it does operate like a wastewater treatment plant.
And so, explain to me, how does that work? You have wastewater coming in. What happens to it to get the valuable products and the water on the other end?
So we take the wastewater coming into the system, from various pig farms, dairy farms, beef digestate, etc., comes into the front end of our system, and we sequentially pull out particles. It's a particle separation system in its essence. We're pulling particles out from larger particles all the way down to micronutrient particles as we sequentially go through the 3 stages of the system. When we take off the large particles, those are organics and really good nutrients, phosphorus, macronutrients we can use for solid fertilizers. And then we go down sequentially into very small micronutrients where we're pulling out potassium, nitrogen. And in that case, we can use that as a liquid fertilizer in a very dilute form. It's spread on lots of land, but in the concentrated form we pull it out on, it's like any sort of liquid fertilizer you would buy in a store. And then at the end of all of that particle removal, we have clean water.
How does this compare to traditional methods of wastewater management? What's new and innovative here, and how is that 3-stage system different from what's typically done?
Yeah, that's a good question, because when I say it's a miniaturized water treatment plant, that probably doesn't get to the essence of what we're really doing, which is capturing valuable nutrients from farm waste. In a municipal water treatment plant or in an industrial water treatment plant, you're simply trying to remove anything that is contaminating the water. And you have excessive budget to do that. You have water treatment operators that run 24 hours a day operating the equipment, and you have a long amount of time to have settling ponds and all sorts of equipment put into the system. Millions of dollars go into those water treatment facilities. What we wanted to do was do something for a very economical price tag. Farms don't have a ton of capital to be putting into their water treatment, and so we wanted to do the most capital efficient and most automated process we could possibly create. Farms also don't have access to water treatment operators, so we had to have a system that could be self-flushing, self-cleaning, fully automated, so that the biggest task for the farms was to make sure the manure gets to the system. Not running systems, not going through learning, months of training, certification to run this system. We want something that can go out and be really intuitive and run right away. So the biggest things we've made when we've changed this from industrial water treatment was automation. And then, of course, specifically designing something for manure. It's a very sticky waste. It's hard to pull out of dilution. It's very mixed. It's mixed really well. It's really homogeneous mixture, I guess I would say, into our system. So to pull that out, we had to develop a specific particle removal system. We don't see these in traditional water treatment facilities, but we were pulling out value from manure. Manure contains 14 of the essential nutrients we need for crop growth. This means things like carbon, of course, but magnesium that our crops are deficit in, and micronutrients that we don't see in a traditional NPK fertilizer. So we wanted to make sure we got all of that value out. So we created something that was focused on valorization of those particles, not just traditional water cleaning.
It sounds like, I guess in some ways, you're moving from a paradigm of contaminant removal to nutrient extraction. Is that fair to say?
Absolutely. Absolutely. I mean, we came from a water treatment background, so we were really focused on creation of clean water. And when we came into this market, we saw that what we really needed to do was valorization of manure constituents. There's value there that we don't see in industrial water treatment. We weren't able to, in traditional oil and gas water treatment, we weren't able to remove jet fuel from the water stream and then reuse that jet fuel. So there was no valorization we could create. In this industry, we can create value here, which pays for the system and creates a really positive ROI for everyone, which made us jump into manure with both feet and get really excited about what we could do here.
So you've mentioned a focus on creation of clean water a couple times. Can I ask, how clean is the water? If we were in the same room talking today, could you offer me a glass of the water to drink?
Yes, I mean, we create potable water. When we are looking at drinking water, we would add another step onto our traditional system so that we could, as a safety check, so that we could make sure that nothing broke through in any part of our process. But yes, we can definitely drink the water. We have lots of times. I do all the time. It isn't focused on drinking water. We're focused on irrigation water, and we work in areas that are very drought impacted. So we really want to not waste any water, having any runoff or anything. We want to pull out all that water for use back in the barns, back with the animals or with irrigation. So we're focused on that type of water, but it can be, we can produce drinking water, and some people want us to.
No, I understand you started your career in the oil and gas industry, or at least previously had a career in that. If that's accurate, how did you go from wastewater and, I guess, cleaning up elements in the oil and gas industry to the livestock industry?
Yeah, it was, if anyone said to me I would be treating manure 20 years ago, I would not have believed them. But we started off treating wastewater from the oil and gas sector. Being a Calgary company, we were really focused on the energy sector and worked in that for several years until we were approached actually by an Alberta pork producer who was looking for a treatment system or some way to deal with an excursion they had from their manure lagoon. This was the first exposure I'd ever had to the livestock industry and to manure lagoons generally. And once we saw what that market was dealing with and the amount of wastewater they were dealing with zero technology able to be purchased, we knew this was a water treatment opportunity more so than an agricultural opportunity. And from then, we just fell in love with the whole industry in general, with the producers, with what they're trying to do, with really looking at how our food is produced. It became a real passion project. We just really got absorbed in it. And it was really market-led. The market was looking for a solution, and there was nothing available.
As you know, ERA, the organization I work with, is focused on greenhouse gas emissions reduction. Now, this technology sounds really exciting so far, but can you explain how it reduces emissions and relates to climate change emissions reductions?
So we were partway through our development in this company when we started thinking, if we were pulling out this much carbon and organic from the manure streams, we must be impacting greenhouse gas emissions. When we looked at some of the farms and we studied some of the farms we were working on, it was between 52% and 82% emission reduction when compared to traditional lagoon storage and then lagoon storage and subsequent land application of that manure. So 52% to 82% reduction in greenhouse gas emissions sounded amazing to us. And we have then since spent time trying to figure out how to create value from that at how that impacts the planet, how bringing that carbon back to the soil can impact our crops, and then how bringing it back to the soil can impact CO2 emissions globally. And we have a farm in Washington State that will be our first farm. It's a dairy farm. We have first farm validated as able to sell carbon credits based on one of our system installations this year in 2023.
So 52 to 82% reductions, if I got those numbers correctly, with nutrient recovery on top of that. That does sound pretty amazing. But can you give me a sense of scale here? How significant are the emissions, greenhouse gas emissions, related to wastewater or to, you talked about lagooning, for example?
Yeah, so livestock in general, I believe, are about approximately 14% of the greenhouse gas emissions on the planet. Part of that is from enteric methane production, so that's from cow burps, and a smaller part of that comes from livestock manure handling. So while we are kind of a small part of the entire global greenhouse gas emission, it's a really manageable situation. It's something we can make an immediate impact on because methane is a short-lived CO2 or short-lived greenhouse gas. We can make immediate changes to this process to reduce that by 82%, which actually correlates to a direct net cooling impact, which is pretty impactful. We can take our farms from being, especially when we're talking in Alberta, we're talking about beef producers, we can take that from being a greenhouse gas emitter to being a greenhouse gas sink, which globally impacts that 14% in a significant way.
So I understand that the company started with a fairly clear goal of zero carbon food production. Where we're sitting today, do you see that goal as achievable or ambitious, or perhaps both? And do you have any major milestones to sort of report in the achievement of that goal?
I think it's absolutely achievable, wholeheartedly achievable. We've already seen significant strides towards that, and we see companies like Maple Leaf Foods being as a Canadian company, being a carbon neutral meat producer. So they're leading the charge in this. This is absolutely achievable. We are, even as a small business out of Alberta, we are already treating 1 billion gallons of manure annually while recovering clean, reusable water, reducing those greenhouse gas emissions. Our goal is to transform 1 trillion gallons of manure and food waste bioliquids by 2050. Together in 2022, we added this up for our year in review. Our customers mitigated over 300,000 tons of CO2 equivalent through manure processing. So to put that into perspective, maybe, and comparable greenhouse gas emissions, that would be driving 750 million miles or 1,500 round trips to the moon. So it's significant, even just what in the impact we've made so far. So this can make an absolutely significant and achievable impact to the planet.
Now, I'm curious, could this technology be used for other applications in the agriculture industry, or maybe even outside of the industry altogether?
Yeah, so we are working in, we're mainly focused on the livestock industry, but we're also working in food production. So any waste coming out of a food production facility, this can be mushrooming or egg washing. Mushrooms grow on manure. Eggs are produced through farms. So, kind of in that agricultural stance, but in a different place than livestock. We are also working on food waste digestate. So any sort of food waste post-consumer from green bins even, or from, facilities that are making fast food. We're seeing waste coming from fast food into this restaurant waste, coming into digesters, and then we are treating the digestate after that. So, food may be generally focused, but not always agricultural waste like manure or crop residue, but all the way up the chain in food waste. We have had requests to look at small municipalities as well. And that is something in our technology roadmap as we move forward to see if we can make a significant impact into small municipalities that are looking for waste treatment.
Emissions Reduction Alberta takes action on climate change and supports economic growth. Our funding helps new and existing industries in Alberta reduce emissions while lowering costs, attracting investments, and creating jobs. That's why, since 2009, we've committed $884 million into 246 projects valued at $7.1 billion in public and private investments. To learn more, visit eralberta.ca.
You talked about a goal of 1 trillion gallons. How does that compare to, let's say, the global livestock water that needs to be treated annually? Is that a number that's publicly available or could be estimated?
We sort of look at the number of cows. It's not really publicly available numbers that we can get, but we do look globally at the number of cows and pigs. So there's 1.5 billion cows on the planet and 800 million pigs. So when we're talking about what we can do with the planet's waste, we look at how many cows and pigs we're going to treat. And then we look at quantifiable metrics like how much energy we can produce from that waste and how much greenhouse gas emission we can mitigate from that type of wastewater. And then as we grow, we're looking at, globally that food waste as well. And that's something we haven't really been able to put a number on. But I mean, if you can imagine, it's significant from what we've already done. 1 trillion gallons of waste. Actually, I have that number of farms here, but it's completely achievable. We have that in our 5-year plan as far as how many farms we need to access to get that. So we're well on our way.
And so I take it 1 trillion gallons would be maybe a small percentage of the overall global amount.
Yes, it is. Our market expansion looks at 30% of the global market for this, and 1 trillion gallons falls into that.
Okay, so you touched on this already, but if we were dreaming big, just how significant of an impact quantitatively could this technology have globally in terms of greenhouse gas emissions if you were successful with livestock and municipalities and other forms of animal wastewater, whatever the case may be?
Well, if we're talking globally about greenhouse gas emissions, we're looking at 10 to 20% reduction globally on that. That creates a net cooling effect on the planet. When you talk about livestock waste, it's not just the emissions from the waste, it's what then that wastewater turns into. This is displacement of traditional fuels. So the impact of renewable natural gas made from biomass. And, the U.S. is looking to displace 20% of traditional fuel with renewable natural gas. So then, we talk about, okay, we've taken the manure out of the lagoon, and that's, 14%, livestock represents 14% of greenhouse gas emissions on the planet. But then it turns into displacing 20% of the transportation industry gas. And so we displace greenhouse gas emissions from the transportation industry. The U.S. is talking about displacing home heating with renewable natural gas. So then we're displacing another greenhouse gas emitter. We're also talking about displacing traditional fertilizer with manure fertilizer. In that case, we're displacing that greenhouse gas emitter. So you add all those up together, it has a massive impact on the planet, not just, okay, we've taken away that manure methane emission, but we've turned it into places that reduce emissions in other places. So when we're working through a full life cycle analysis right now with the federal government in Canada so that we can quantify each stage of that and talk about how much this valorization of waste can turn into a net cooling effect on the planet.
I love that interconnectedness between industries and the opportunity to tackle greenhouse gas emissions beyond just the livestock industry. So that's fantastic. Now, as you know, the government of Alberta, through our organization, ERA, is partnering with your team and providing some funding to showcase and demonstrate the technology here in the province of Alberta. Can you tell me about that project and what the overall objectives are?
Yes, so that project is first and foremost to demonstrate our technology here in Alberta. This is a Calgary-developed technology created in Alberta, and then we are spending most of our time working internationally. We wanted the ability to have a showcase in Alberta where we could partner with one of the world's largest food producer and showcase how Canadian technology could affect change throughout the food industry. Traditionally, when we've had investors or clients or potential partners come to meet with us, we've had to meet with them in Wisconsin or Washington where they could look at our system in action. And we wanted to work with ERA to develop a demonstration project in the province. Now, a few impediments stood in our way, and one of them being that we needed to get the attention of the largest food producers in the world as a small business. ERA provided us with the clout to approach them and say, we have, first of all, some assistance with funding on the capital, but also we've been vetted by this group that can, help us not just come across as a small technology company, but actually the province has put their faith in us to work on something like this. So first off, we wanted to showcase here in Alberta. Secondly, Alberta is cattle country. We have more than 18,000 cattle producers here. As I said, we have more cows than people here in Alberta. So we wanted to showcase to Alberta producers what can be done in here. I believe that Alberta can lead the transition in energy to renewable energy because we have so many energy professionals here in the province. We have all of the tech talent here, and showcasing what can be done with some wastewater into an energy production, into clean water and fertilizer, that full-scale ag and energy connection. Here in Alberta, my mind set was this could turn it into something way more massive than just one single project. ERA was essential for that. There's simply no way we could have done that project without ERA. We didn't have the capital to work on a demonstration project, and we didn't have the backing.
Can I ask, how will you know if the project has been successful?
So it's working in conjunction with other projects we have on the go right now. And we are doing a life cycle analysis of all of the impacts we can make through our technology in different stages of the food production chain. So that comes from the farm, waste on the farm, be it crop residue or manure waste, then food production waste. So that's where the ERA project is focused on right now, is food production waste. And then our next level is retailer and post-consumer. So we also have another project in that space. So we can add up all these spaces together and then do a full life cycle analysis of what we can do with waste all through the supply chain. If you look at the supply chain of food, profitability is, from beginning to end, a very small amount of that profitability is in the farm. A medium amount is with the food producer or food processor, and then the largest amount is with the retailer. So we're working with all those groups to look at profitability, where the spend should be on environmental work, and then the life cycle of how we can impact all of those. So this food processor part that we are working with ERA on, this was essential. We didn't have any other projects that were in this space to be able to complete that full life cycle analysis.
Now, I understand your team was also part of ERA's Innovator Support Pilot Program. Can you tell me about your experience in that program and what the benefits might have been?
Mm-hmm. So, if anyone has ever worked in a small business or a startup before, you will understand that it's intensely difficult to move from innovator to commercialization, and mentorship and guidance is key to doing that. There's no way, as a CEO, I'm going to know all aspects of how to move forward. And that pilot was so helpful in connectivity, mentorship, advisement in general, overall as of businesses, all stages of that. It's essential to have that help. And ERA was exactly what we needed to resource that at the time. I'm a zoologist by background, and so there's many parts of this technology I'm comfortable with, but many parts of commercialization and business opportunity that I have needed mentorship and advisement on, and that's what we look to that for.
I understand you've also had a fair amount of media coverage for the technology, the Toronto Star, Financial Post, Forbes, and now you're getting showcased on Carbon Copy. That all must be really exciting. Can you tell me what that's been like?
Yeah, it's been amazing. I think that, in my opinion, Manure is the most exciting opportunity on the planet. But of course, I love to talk about it. I'm very passionate about it. But I've really been so surprised and happily surprised by the amount of interest we've got. I think that creating value from waste is a universally beloved topic. Nobody stands against this. Yes, people can say it needs to be economic, but everyone loves the concept of taking a waste product and turning it into something valuable. Every time you throw something in the garbage or drive past a landfill, you wish that waste went somewhere to magically transform into some value. And we're doing it. We're doing it every day. Plus, saying we make clean water from poop is a pretty fun concept. I know my 6-year-old nephew loves talking about it. So I think that people just have really embraced that and been so supportive in the sector.
Now, you were also at the big COP27 event in Egypt. What were some of your key takeaways from that experience?
That's a good question. COP was a very eye-opening event, actually. Even us, we work internationally. We have a project in the Middle East. We have projects in Europe. We have a project in the UK. And we're working throughout 12 states in the US. So even as we look globally at this issue, COP really told me that I'm not looking big enough. I'm not looking globally enough. We really need to look at this energy transition more aggressively. And I always say Alberta can lead this. We have everything available to us to lead this transition. And, COP told us that we weren't there yet. We weren't meeting our obligations. I think Canada was the only G7 country that hasn't met our goals. And that makes me sad as a Canadian. I think that we are working really hard to get there. And I think the energy transition is the part that needs to move faster.
What are the next steps then for you and for the livestock water recycling team?
We are looking to grow very aggressively. We're scaling very aggressively over the next 2 to 3 years. We are expanding in the U.S. At a rate that is not what we expected. It's going faster than we had anticipated. So we've made partnerships here in Calgary with people to help us scale our production facilities. We moved in April into a facility double the size of what we were in before, and we are already out of space. So we've created partnerships here to help us build. And as things come back online after the pandemic, we are really seeing growth in our future. The renewable natural gas sector in the U.S. is massively growing to create energy security in the U.S. And then we're seeing this follow suit after the U.S. in every other country in the world. I was just in Japan before Christmas, and we were seeing multiple projects going ahead there with Canadian digester companies and our technology as well to produce renewable natural gas from waste there in Japan. So every country is working on energy from waste, and that's really driving us forward. As well, we are working on, of course, nutrients from waste. When we saw the issues begin in Russia and we were unable to put crops in the ground in Canada because we weren't able to get fertilizer from Russia, that really was an eye-opener for a lot of people in North America to say, we need our own fertilizer. We've seen massive investment from the US and from Ontario into homegrown fertilizers. And so we're, again, pulled into the market in that way to try and create more fertilizer. And then as drought conditions continue in our climate, we're pulled towards water. So we're really at an intersection of fertilizer, energy, and water needs in the market. And so that's just going to push us to grow massively.
Now, if my math is correct, your company was in business for about a decade before it really started garnering such high-profile interest. One could say you were excited about Manure before it was cool, a bit of a poop hipster perhaps. Do you have any advice for startup companies and innovators inside and outside of the agriculture industry that may be where you were at 10 years ago?
Oh, geez. You feel like you can't give advice. But the best thing we did, we came from outside this industry and brought a water treatment solution to the agricultural industry. And we were bringing a solution to a problem that we saw, but the agricultural industry didn't really see yet. So the best thing we did was go and talk to the producers, talk to all the farms. We talked to hundreds of farms. We treated thousands of manure samples before we were able to find something that was economical and efficient enough to create value instead of just being a cost to farms, but actually be a value producer for farms. So that's the biggest piece of advice is don't be producing a solution for a problem that you don't know about, but identify the problem really coherently before you work on your solution for it. It really took us time to get from where we patented the technology to where we produced it in a way that made real sense for farms and made real ROI in the business.
Well, this has been a fascinating peek into the world of livestock water recycling and an exciting innovation that's helping to tackle the global climate challenge. If people want to learn more and follow your team's progress, where can they go?
Please go to our website, livestockwaterrecycling.com, or any of our social media platforms. We have a newsletter that goes out every single month called Fast Facts by Lisa Fast, our marketing manager. And that has a bunch of exciting developments in the market in general and then about us. But you can sign up for that newsletter on our website. We don't send you any other spam, just no other manure problems coming into your inbox, just our newsletter every month. And then we send out a lot of interesting facts about the industry, about the energy industry on Facebook, Instagram, Twitter. We're on everything.
So last question then, is there anything we didn't talk about that you'd like our listeners to know? Anything I didn't ask you about or any closing thoughts that you'd like to leave us with?
I think I'd just like to stress again, and maybe, I've said it a lot, but when I think about across the prairie provinces, there are millions of cattle. And Can you imagine what we could do with that energy and that fertilizer? It doesn't need that much investment into it, and it creates a really massive ROI for everyone in the prairie provinces. We just need to embrace the idea of transition.
Thank you very much for your time today, Karen. It was truly awesome talking with you.
Thank you, Mark.